Hello friends, welcome to Ideal Tutorials committed to excellence. For more videos, please subscribe our channel.
Okay, metals are those elements which conduct electricity and of course heat, and they are malleable and ductile. Malleable means they can be converted into thin sheets, and ductile means they can be converted into thin wires. Examples for the metals are iron, which is Fe, aluminium Al, silver Ag. Then we have non-metals. Non-metals are the elements which do not conduct electricity nor conduct heat. They are also not malleable and ductile. For an example, carbon, sulfur, phosphorus, chlorine, silicon, hydrogen, etc. Here is the difference between metals and non-metals. So read it, learn it, and write it in the exam. They are solid at room temperature except mercury, which is liquid. Sound, they produce sound. Therefore they are known as sonorous. Malleability, they can be converted into thin sheets. Conduction, melting and boiling point, they generally have high melting boiling point. Density, they have very high density. Then we have color, they can be green color. Elements like gold and copper are the exceptions. Then we go to non-metals. Hardness, they are generally soft except diamond. Diamond is very hard, we know that. State, they can be in any state, solid, liquid or gas. Luster, they are in dull appearance. Example, sulfur. Except diamond and iodine, they are very lustrous. Sonority, they are not sonorous, they cannot produce sound. Conduction, they do not conduct or they are a bad conductor. Malleability and ductile, they are very brittle, therefore cannot be converted. Melting and boiling point, they generally have low melting and boiling points. Density, most of them they have low density. And color, there are many colors, they are of different colors. Now here we go with chemical properties. First of all, chemical property of metals. They react with oxygen to form metal oxide. Metal plus oxygen give rise to metal oxide. Example, potassium plus oxygen give rise to potassium oxide. Next here, they react with water to form metal hydroxide and hydrogen gas. Sodium plus water give rise to NaOH, that is sodium hydroxide, and hydrogen gas is liberated. Then we have chemical properties of non-metals. They react with oxygen to form non-metallic oxide. For an example, carbon plus oxygen give rise to carbon dioxide plus heat or energy. Then we have the reaction with chlorine. They react with chlorine to give metal chloride. For an example, hydrogen plus chlorine give rise to hydrochloric acid. Metal oxide are basic in nature, therefore they turn red litmus paper into blue. Metal oxide, the reaction of metal oxide with water. All the metal oxides are insoluble in water. Alkali metal oxides are soluble in water. Alkali metal oxide gives strong base when dissolved in water. Then the reaction of sodium oxide with water. Sodium oxide reacts with water to give out sodium hydroxide. The order of the reactivity of metal is known as the reactivity series. The reactivity of the elements decreases on moving from top to bottom. The reactivity series is given below, and the descending order of the metals is also given below. Then we have ionic bonds. Ionic bond is formed by the transfer of electrons from metal to non-metal. In this, the metal which give the electrons contains positive charge, and because the non-metals gain the electrons, they contain negative charge. Then we have formation of sodium chloride. Sodium has valence electron 1 and chlorine has 7 valence electron. Therefore sodium give its 1 electron to chlorine to complete its bond itself and to complete the bond of or the complete the electron of chlorine as well. Then we have the charge sodium plus 1 and chlorine minus 1, and therefore sodium chloride is formed. Then we have extraction of metals. From extraction of metals from its ore, there are some three major steps. First of all, concentration or enrichment of ores. Then we have conversion of concentrated ore into crude metal, and then the last step is refining of impure or crude metal. The flowchart is given below, deriving the extraction of metals. Then there comes the difference between calcination and roasting. Basically, calcination is done for carbonate ores and roasting is done for sulfide ores, and the further difference reactions goes on. And first of all, extraction of metals of least reactivity. Metals like mercury and copper, which belong to the least of the reactivity series, are found in the form of the sulfide ores. So basically the ore of mercury is known as cinnabar, HGS, and first it is heated in air, then this mercury sulfide, or we can say cinnabar, converts into HgO. This is mercury oxide by the liberation of sulfur dioxide. Then mercury oxide is then heated strongly and it reduces mercury oxide into mercury metal. Then the second comes the extraction of metals of middle reactivity. Metals like iron, zinc and lead are found of carbonate or sulfide ores. The carbonate and sulfide ore are first converted into their respective oxides and then are reduced to respective metals. For an example, extraction of zinc, the ore of zinc is known as zinc blende, that is ZnS, and we can say that ZnCO3 is also the ore of zinc. Then zinc blende is roasted into and converted into zinc oxide, and zinc spar is put under zinc spar. What is zinc spar? ZnCO3, that is the carbonate ore of zinc. Then this zinc spar is put under the calcination to be converted into zinc oxide. Here comes the extraction of metals of high reactivity. The metals of high reactivity such as sodium, calcium, etc. are converted or extracted from their ores into the pure metal by electrolytic reduction. The process of electrolytic reduction is as follows. Electric current is passed through the molten state of metal ores, not by the solid state but molten state. Metal being positively charged is deposited over the cathode, and impurities belonging to the negative charge are deposited at the anode. For an example, electric current is passed through the molten state or solution of sodium chloride. Then sodium is deposited over the cathode and impurities at anode. Then we have electrorefining of copper. In copper, the lump of impure copper metal and a thin strip of pure copper are dipped in the solution of copper sulfate. The impure metal is connected with the positive pole or positive electrode, and the thin strip of pure metal is connected with the negative. Then the electric current is passed through the solution. Pure metal is deposited over the anode and moves towards the cathode and deposited over it. Impurities present in the metal or settled near or bottom at the bottom of the solution start depositing on the anode. Settled impurities in the solution are called as anode mud. Then here comes alloys. The homogeneous mixture of two or more metals or a metal and a non-metal is called an alloy. Then what are the properties of alloy? Alloys are stronger than metal from which they are obtained. It is harder, obviously, more resistance to corrosion. The melting point of alloy is lower than the constituent metals. For an example, solder Sn 80% and Pb 50% has lower melting point than lead and Sn. The electrical conductivity of alloys is also lower than the constituent metal. Then here comes some examples of alloy. Brass, it is an alloy of copper and zinc. Bronze is an alloy of copper and Sn. Solder is an alloy of lead and Sn. Steel is an alloy of iron and carbon. Stainless steel is an alloy of iron, chromium and nickel. Alloys of gold. Pure gold is said to be of 24 carats, and therefore it has to be converted into its alloy to make it hard and to make from it jewelry. Then gold is an alloyed with small amount of silver, or we can say that copper, to make it hard. So thank you so much guys. Keep learning and stay tuned with us for our further videos.